Multiplying powers with the same base is going to seem like a lot of rules that I'm throwing at you, but we're going to try to address this as looking at the expansion of each of the powers so that you can build the rule yourself. That was how I dealt with it when I was in school. I couldn't memorize all the rules, but I knew that 3 to the 4th power meant 3 times 3 times 3 times 3, and so I would use that to remind myself of the rule, as you're going to see in this video. Our target is that I will simplify expressions using the exponent multiplication rule. So remember, the exponent, which in this case is 4 and 3, that tells you how many times the base, which is the big 3, is being multiplied. So something like 4 to the 3rd expanded out is 3 times 3 times 3 times 3. There are 4 3's being used right there, whereas 3 to the 3rd is going to be 3 times 3 times 3. Now we know from the use of exponents that you're however many times the base is being used, that is the new exponent. So I can go through here and I can count. I have 1, 2, 3, 4, 5, 6, 7 3's. So I can conclude that that is equal to 3 to the 7th power. Now hopefully what you're catching on at is that 7 comes from the 4 and the 3. I am adding the exponents. So here is that rule spelled out for you. When you are multiplying powers with a common base, so notice these both have 2's, like this would not work for 2 to the 3rd times 3 to the 4th. It does not work for that. It has to be a common base. When that happens, you add the exponents, 3 plus 5. So let's say it's test time and you have forgotten the rule of what to do. Expand it out and then count how many bases you have. Or if you know the rule, you get enough practice with it, you recognize that to do 8 to the 3rd times 8 to the 6th, you're really doing in your head 8 to the 3 plus 6 power, which is 8 to the 9th power. This part right here, that is going on in your head. I'm not expecting you to write that out at all. For this second example, 0.5 to the negative 3rd power times 0.5 to the 6th power, even though we know that negative exponent is going to push it down to the denominator, I can bypass that and go ahead and add these exponents. Negative 3 plus 6, so I have 0.5 as a base, would be equal to 0.5 to the 3rd power. And we're practicing with the rules and not necessarily evaluating those exponents, so it's completely okay to leave it in that exponential form, because something like 8 to the 9th power is going to be a huge number, so leave it as 8 to the 9th, leave it as 0.5 to the 3rd. I can do this when I have 3 powers being multiplied together. In my head, I'm saying that is 9 to the negative 3 plus 2 plus 6 power. So I have a base of 9. Negative 3 plus 2 is negative 1. Negative 1 plus 6 is 5. So that would be 9 to the 5th power. So let's see how this applies to algebraic expressions. It's going to be dealt with the same way. Instead of having a number as a base, you have a variable as a base. So the example we have is 5x to the 4th times x to the 9th times 3x. This is the same thing as 5 times x to the 4th. You already know that when the number is next to the variable, that is the same thing as multiplying. So think of it as completely expanded out like this. So what I can do is I can use the commutative property. I can rearrange the order and I can multiply those coefficients first, 3 and 5, and that's going to give me 15. The second step is I'm going to multiply the powers with the same base. So I have x to the 4th, x to the 9th, and x. Think of that singular x right there as x to the 1st power. So then to multiply all this together, I add their exponents. 4 plus 9 is 13, and 13 plus 1 is 14. So the simplified version of that is 15x to the 14th power. Let's look at multiplying with scientific notation. We're going to use that same principle that we saw in the previous slide of kind of reordering things. It's all multiplying, so I can use commutative property and reorder. I can go ahead and multiply 3 times 8. 3 times 8 is 24 times 10 to the 5 plus 4, which would be 9. Now you need to remember a key fact about scientific notation is that this first number here, the factor, it has to be between 1 and 10. So I'm going to need to move that decimal over one spot, which is going to increase that exponent. So it's going to be 2.4 times 10 to the 10th power. So I used commutative property reordering. I did associative property in that I switched how the groupings were. I grouped 3 and 8, and I grouped 10 to the 5th and 10 to the 4th. Got 10 to the 9th. I noticed it was 24 times 10 to the 9th, and I had to move that decimal over to make that first factor between 1 and 10, so that makes my exponent over here go up by 1. Okay, looking now at simplifying expressions with rational exponents. So we have an expression here. The exponent is a rational number. It's a fraction. So 16 to the 1/4 power. What should be going on in your brain is you're asking yourself, what number can I multiply by itself 4 times and get 16? So the number that I'm wanting to know, what number times itself 4 times equals that? So the 1/4 is basically undoing the 4th power. And just use some trial and error. Start with 2. So if I did 2 times 2 times 2 times 2, let's see if that works. The factor used 4 times. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Therefore, 16 to the 1/4 power is equal to 2. Now another way to think of this, when you have the 1/4 power, that's the same thing as the 4th root. You may not be as familiar with 4th roots, but you've definitely seen square roots, and you've probably seen cubed roots. So if I had 25 to the 1/2 power, that is the same thing as me asking what is the square root of 25, which would be 5, because 5 times itself twice. 5 times 5 is 25. So using 25 as a base again, let's see this one worked out. So if I start with 25 to the 3/2 power, 3/2, that can be expanded out as 25 to the 1/5 power times 25th to the 1/5 power times 25th to the 1/2 power. That works because from what we've seen earlier in the lesson, 1/2 plus 1/2 plus 1/2 is 3/2. By expanding it out, I can see this a little clearer. So 25th to the 1/2 power, that's the square root of 25. That would be 5. So then 5 times 5 times 5, because they're all 25th to the 1/2 power. So that would be 5 to the 3rd power. Or you could, if you know that one, that would also be 125. But I would accept either one of those answers. Let's put all of that together into this big, crazy expression. All of these are multiplying. It's 2 times j to the 2/3 times 7 times m to the 1/4 times 3 times j to the 1/6 times 4 times m to the 3/2. So let's mark the ones that I can multiply together. I know I can multiply the coefficients 2, 7, 3, and 4. So 2 times 7 is 14. And then 14 times 3 would be 52. 52 times 4 would be 108. Okay? Then let's look at the variables with the same base. Let's look at all the j's. So I have a j there and a j there. There we go. So I'm going to add those exponents. So I'm going to write this out a little bit more. I would have j to the 2/3 plus 1/6. And then I have the m terms to deal with. Let's do smiley faces for the m's. I have an m there and an m there. So that's going to be m to the 1/4 plus the 3/2. So let's go through and add those exponents now. So 108 is 108. 2/3 plus 1/6, that would be the same thing as 4/6. So that's going to give me 5/6. And then m, 1/4 plus 3/2, that would be like 6/4. So that's going to be 7/4. And that is my simplified version. 108, j to the 5/6 power, m to the 7/4 power.